So this is a question that I found on Twitter, which is called, which involves conditional unpacking, and the question is, what is the output of this following code? And we could, of course, just run the code and find the output, but more case of let's just go into some of this, and I might just comment this out for now, just and then we'll have a look. But the first question is, I guess, what is unpacking? If anyone didn't know, that we could say something like x, y, and z is equal to, and we could give our values like 100, and then, for example, I don't know, we could use true, and this would unpack, and then we could do print x and y, and what we get, we can actually even print them separately. I'll do both. We can, down below, if we see, we get 100, and then we get true just down here in our result when we run our piece of code. Now, we could also print just x, and we could print y, just to show that they aren't connected in any way, and we could just run our code again by pressing F5, and we get 100 above and then true below because we printed x. X gets assigned the value of 100, and y gets assigned the value of true. So it's literally like this. X gets the first value, and y gets the second value. And we could continue with this theme of unpacking, so this extends in Python. So we could add more things in, for example, z. They don't even have to be of the same type. This is a nice thing about Python, it's quite flexible. So x is an integer, y is a boolean, z is a string with my name, Darren, and we could again print z. We could even print any combinations. We could print like y, and we could also print z and so forth. We could do all types of these things, but the point being that this unpacking just basically unpacks each item. So again, x unpacks here, and y unpacks here, and z unpacks over here. So z gets the value of Darren. So we should expect to get 100 true and Darren. That's what should come out of it all. So we run the code again, press F5 to run the code, and we get exactly that. So now we know what unpacking is. That's sorted. Unpacking is sorted. Now, what is conditions? Because we've got some form of unpacking here. We could imagine that all of this over here was the value of x. That's kind of like how we're going to look at this question. So everything basically in this box here is what we're going to ascribe to the value of x, and the other piece here, which is y, is going to get none. This is what we feel is going to happen. So we've kind of like debunked or solved half of the mystery, in the sense that we know, at least we know what y is. But what is this 0, 1, if true, else none? Okay, so how do we interpret this in Python basically? So I'm going to say that let's just put this down as conditions. So we'll write this down. We'll call this print. Okay, we're talking here about unpacking. So that's our unpacking section over there. And at the end of that, we can then stick, I guess, a whole bunch of dashes in here. So that's the end of our section. And now we're going to look at conditions. So I'm just going to call it conditions, I guess. There we go, conditions. And at the end of it, well, we can stick the triple line just to show where we've started and finished. So what are conditions here? And we're faced with this, that x equals 0, 1, which is a tuple. This thing here is called a tuple. You can think of it as an item. If true, else none. Right. Now, this again looks a little bit complicated, so we need to, like, and by the way, this question that was written that's already down here now, because it's moved down a lot of lines, is written in this way on purpose to be confusing. This isn't really, although like you could say that it's very powerful and concise Python code, I'm actually going to say that it's confusing to the user in the sense that without a comment, you'd really have to go through these processes to, in your mind at least, to debug, to think, to figure out what the actual answer is going to be. Now, we have this here, and generally speaking, in our what we normally face with our conditions, so the regular type of condition is if x equals, or sorry, if 0, 1 is equal to true. I'm doing this all. I'm actually doing this all live, although it's a video. So this is first time out. But this is kind of like how you should think of it. And this is, and I wanted to do this first time out without any like pre-do, because this is how you should think about it when you're first hit with one of these things, when you look at a piece of code. Whereas if I pre-planned it, then I was kind of like just go and spit out the answer and go very quickly in doing this. So I'm actually kind of like live debugging what this question is, although I actually do know what the answer is, but I'm live debugging how I should think about it. And actually I did cheat, because I just put all of this in and then did print text and ran it, which is, you know, the kind of like, we'll call it the cheat way. But anyway, if 0, 1 equals true, then we want to print, I guess, I'm just trying to think of the logic for this, but naught 1 if true. Right, so I'm just trying to think of the best way of describing this now, and even actually for myself. So I think that I'm going to go with this, which is, I'll keep along these lines. So basically, this is our test condition, if 0, 1 is true. And then we are going to, well, first we'll just assign, we'll just say that x equals, I wonder, 0, 1. If true. I'm wondering what is tested if there is a true here. I think that this is automatically run. So basically, if true is always going to be the case. So if you've got an if true, then it's always true, and it's a bit like a while loop actually. So this is quite an interesting one, because like you get this quite often, but while true. Some people put this in, and this runs code indefinitely. This while loop will now run forever, because you just set your condition to true. So this thing here means that x is always going to be 0, 1, because true is always true, and it's never going to be none. So that means that I'm going to say that x is equal to 0, 1, I imagine. Would be as simple as that. X, if true, is always going to be true, otherwise it's none. So I think it might be as simple as that in the conditions. And I guess if I was replicating this, that we'd have, because this condition, so we'd have this if statement, so if, and then we've got some condition here, and normally you'll be testing for something like, I don't know, a equals 100, right? That's our test condition here. So if a equals 100, then let's say x equals 0, 1, right? That's our condition that goes in here. But for our case, and this is going to evaluate either to a true or a false. Now, we're already told that this is true. So what we've got is an if true here. And then we've got an else none. Now, this piece of code here is always, or this expression is always evaluating to true, so this else will never run. And in fact, like the hint has already come. If you can see that this is slightly grayed out compared to this one, this is never reached. And in fact, it says it here in the linter. I just hovered over it and it says code is unreachable. So the reason the code is unreachable is because this if true is condition is always satisfied, and therefore x must be 1. So I presume that if we did a print of x, that we're going to get whatever is here. Now, I'm just going to change this to, so not have 0, 1, because that might look confusing, but put hello. Right, there we go. X equals hello, if true, else none. So that's what that could, we have broken down that condition to something a bit more simplistic. And hello, and this is the comparable version. So this is what the, what's it called here, by the way? This is called the conditions part of it. So the conditions. So Python has offered us two ways of doing an if-else statement. So one way is like this. We could even make it, we could simplify it to kind of like put it all on one line like this. So there we go, that's quite nice and concise version. But the other way is to talk of it like language, and Python offers this to give some flexibility to users. So you can say hello if true, else none. But really it's hello if there is some condition that might be true or might be false. It's got some probability. It's not always guaranteed to be one or the other. And actually, you might say this is an error in the linter, because if this is picked up as being grayed out, this none, these two nuns are equivalent to each other. So this none here and this none over here, both can never be reached. So this is more like the English language version, and this is the coding version. And I think the coding version actually in this particular case is actually clearer than the English language version. This is written specifically to, we'll say, confuse. But anyway, we can now, I don't think this doesn't go anywhere, so that's fine. We'll run our little statement, but we'll keep it in the classical format with the indentation, so that we sort of like, this is how we know it. So if true, this is always going to run, x is going to be hello, and then print x. So we're going to get all of these conditions over here in our unpacking, but then in our new section, we're going to get this print of x over here, and we should get hello. So if I F5 to run this again, I might have to extend this a little bit up. But there we get this hello. And actually, finally, the answer, because I forgot to comment this one out, I should have left it one more, but we can now replace this hello again back to the 0, 1. So if we were to take exactly this expression, and in fact, if I was to kind of like put it here, we can already see the similarity of it, that this part here, which is referring to the x component only, so we could say y here is an elephant, right? There we go. So just for the purpose of showing, our x over here is all of this first component over here, and our y component over here. So this is our x, and our y component over here goes to the second component. Now we're just going to change these things again to variables that are potentially a tiny bit more confusing. Is a string any more confusing than a tuple? When you've broken it down into its constituents, it then begins to look easy. So that's exactly what we can do. We can replace this with our tuple 0, 1, which is exactly the same as below, and we can change our string to a none, which is exactly as below, and we've arrived at the answer. And of course the answer is, well, I've already run it, but the answer is, I ran it accidentally, is 0, 1. So the final bit, I guess, is print the answer. So F5, run it. And we get all of the outcomes of everything that we were testing for, and finally at the end we've got our answer, which was 0, 1. So that's basically it. And this is conditional unpacking, which is combining conditions with unpacking. I'm going to say that you should try and avoid these types of things, or just be careful with it if you're going to do that, because unless it's relatively clear, someone's going to have to come by, and this is a great one-liner, but now I've had to come by and decode this bit. The second part was relatively okay because I knew that Y was none straight away. That might be obvious to a coder. You could say, we'll put these on 2 separate lines of code. Let's make this a bit better. Let's say that Y equals none. This is clearer to the reader. And then say that X is equal to all of this. That's potentially clearer to the reader. But again, let's not say that X is all of this, but actually, because we never get to this condition, so it's poorly written, that really what you're actually saying is that X equals 0, 1. And it's as simple as that. So someone's convoluted it and thrown in an effectively over here an if true else none, like a whole statement that just never did anything. And that was basically this part over here. All of this kind of like 4 lines of code was thrown into this little section here, and it nullified itself because X was always going to be equal to hello. In our particular case, X was always going to be equal to the 0, 1. So it was actually as simple as that. So this is a case of overcomplicating code to the point where it's actually, I'm saying nearly, well, it's actually costing you. It's costing you in complexity, and it's actually also costing you, I believe it's costing you in computational time, because here you've just done an assignment of, X to a tuple, and here we've had to throw in a logical check, and even potentially a second logical check. I don't know if it goes through the second logical check in terms of the number of lines of code, but that's definitely what happens. So this is conditional unpacking. I'm going to say that this is probably, unless you've got something relatively clear, not a good thing to do necessarily in Python, or at least use it in the right context how you should. And just on that note, I guess if you found this interesting, then follow the channel. There's quite a few, like, I don't know, interesting things that are here, and also, like, it helps share it with other people. That'd be quite useful. And if you've got any comments, any suggestions, if I wasn't clear on any part of this, because I did, everything that I do, I do in live. And the reason why I do it in live is you get like loads and loads of videos that give you the answers, and they're sort of like predetermined, and the person already knows, and they've gone through it, and they tell you exactly what it is. But that's basically not how coding is done. Coding is done this way. So I'm just trying to do everything live. There's probably a lot of ums and ahs in my videos. There's probably a lot of pauses and thought processes and so forth, and like chopping and changing of code, iterating towards a correct solution. But if you like this type of thing, and we'll call it real coding, and you want to follow a real coding series, shall I call it, then yeah, just like this video and follow and so forth. So thanks for watching.